From the given arrangement, find the force acting between the two blocks. Now this is the arrangement. Here we have a 4 kilogram block and a force of 40 Newton is acting on this block. This block of 4 kilogram is placed on another block of 5 kilogram, and the surfaces between them is frictional, having a coefficient of friction 0.8, and the surface on which this 5 kilogram block is placed is also frictional, having a coefficient of friction 0.1. So as I have told you in the previous lecture, that what we have to check in such a situation, that whether there is a relative motion between the blocks or not. What we have to check, whether there is a relative motion between the blocks, because if there is a relative motion between the blocks, then the situation is different, and in order to have this relative motion between the blocks, the applied force must exceed the force of maximum static friction acting between the blocks. Clear? Because the force of maximum static friction is the parameter which decides whether relative motion occurs or not. So let's calculate force of maximum static friction between the blocks. Let this is FMS1, and it is equal to coefficient of friction 0.8 and the normal reaction here between the two surfaces. Then the normal reaction is the action of this 4 kilogram block on 5 kilogram block, and that is 40 Newton. So our force of maximum static friction is 32 Newton. Now the force of maximum static friction acting between this 5 kilogram block and the surface is the coefficient of static friction 0.1 and the normal reaction. Now the normal reaction means action on this surface below, and the force acting on it is 90 Newton, means weight of both the blocks. So action is 90, so reaction is also 90 Newtons. So it is 90, so this gives you 9 Newton. Now unless the force between these two blocks reaches this value, these two blocks move together with a common acceleration. Clear? Now let's check whether this state can be achieved here between the blocks. Clear? Now suppose we don't know what is the force acting on the upper block. Let this force is F. We don't know. For instance, suppose we don't know what is the force acting on this 4 kilogram block, and this force, whatever it is acting on this 4 kilogram block, has the capacity to generate force of maximum static friction here between 4 kilogram block and the 5 kilogram block, and that is 32 Newton. And if we draw the same situation for 5 kilogram block, due to application of this force F, this 32 Newton force, that is the force of maximum static friction, is provided by this lower block. So here we are drawing 32 Newton. And what is the force acting on this 5 kilogram block with respect to the surface on which these two blocks are placed? It is 9 Newton. Clear? This 9 Newton. And if we look carefully here now, the acceleration of this 5 kilogram block is net force that is acting on this 5 kilogram block is 23 Newton, 32 minus 9 divided by the mass of the block. So 23 by 5 meter per second square. Because due to the application of this force, this 32 Newton has arisen. Clear? And at this instant the acceleration of both these blocks is same. means this is the common acceleration at that instant of application of this force F. So this block also has the same acceleration of 23/5 meter per second square. Now if I apply Newton's second law on this block of 4 kilogram, so I can write minus 32 is equal to mass of the block into its acceleration, and if we solve it, we get force as 32 plus 18.4, and that gives us 50.4 Newton. But in our situation here, what is the force that is acting? It is 40 Newton. This means due to the application of this force of 40 Newton, clear, the force between this 4 kilogram block and 5 kilogram block will never reach this value of 32 Newton, because in order to achieve this value of 32 Newton, we have to apply this much force, means 50.4 Newton, and the given force is 40 Newton. This means that due to the application of this force of 40 Newton, these blocks will keep on moving together with a common acceleration, and they do not have any relative acceleration between them. Now situation has become simple, and we can calculate the common acceleration as the net force acting on the system of these two blocks, and that is equal to 40 minus 9. Now be careful here, it must be 40 minus 9, because whatever the force is acting between these two blocks is the internal force of the system. Only force that is acting on the system is this 40 Newton, and the force here, this force is the force of a maximum static friction that has reached, and that is 9 Newton. So it is 40 minus 9, and mass of the system is 9. So the common acceleration here is 31/9 meter per second square. Now what we have to calculate? We have to calculate this force between these two blocks, and if I use the concept of FBD, so I can calculate it easily. So what is the force that is acting on this block of mass 4 kilogram is 40 Newton, and what is the acceleration of this block, which is same as that of 5 kilogram block, is 31/9 meter per second square. And what we have to calculate? We have to calculate the force, the frictional force that is acting between the blocks, and let this frictional force is F. So if I use Newton's second law, so that gives me 40 minus F is equal to 4 into 31/9, and if I solve it, so I will get the force of friction between the blocks as 26.22 Newton. See how interesting the problem is, because in the initial situation it gives us an illusion that this is 40 Newton and the force of maximum static friction is 32 Newton. So everybody, or most of the times everyone, look for relative motion of this 4 kilogram block with respect to this 5 kilogram block, but this will be a mistake to do so. And in order to solve such problems, you have to be very careful. You have to consider the motion of that block first, which is moving solely because of friction, and here it is the 5 kilogram block, and you have to calculate the possible force that is acting or which can cause the FMS. From here you can have a situation of common acceleration, and unless that common acceleration is achieved, obviously the blocks will move together. Clear? So you will calculate accordingly.